Have you ever really stopped to think about how sweating actually cools you down? Or how a simple clay pot can keep water ice cold on a scorching hot day? Well, today, we're going to pull back the curtain on the science behind nature's very own air conditioner, evaporation. And hey, if you've got exams coming up, you are definitely going to want to stick around for this.
All right, let's kick things off with a classic puzzle. You know how a desert cooler can feel like an absolute lifesaver on a hot, dry day, but when it's humid and sticky outside, it barely does anything? The answer is hiding in plain sight, and we're about to find it.
And here's the really cool part. The solution to our desert cooler mystery? It's the exact same science that explains why you feel a chill after a good workout and how a simple earthen pot keeps water cool with zero electricity. It is all connected.
So what is this big secret? Well, it's all about a great escape, performed by some very tiny culprits that I like to call the energy thieves.
Okay, I want you to picture the molecules in a drop of water, like they're at a crazy dance party. Some are kind of slow, some are moving fast, but the ones with the most energy, the real party animals, they push their way right to the front, which is the surface. With one last burst of energy, they literally leap off the dance floor and into the air, turning into a gas. But here's the trick. To make that final leap, they have to steal a bit of heat energy from their friends they're leaving behind, and that leaves the rest of the party just a little bit cooler.
Now, this whole process has a name you will definitely 100% see on your exams: evaporation. It's how a liquid turns into a gas at any temperature below its boiling point. And you have to remember this part. It's a surface phenomenon. That great escape only ever happens at the very top layer of the liquid. And that stolen energy we keep talking about? It has a proper scientific name: the latent heat of vaporization. Just think of it as the getaway energy that our molecular thieves need to make their big escape. It's a super important term that explains the whole cooling effect. Okay, so now that we get the science behind the heist, let's circle back and finally solve those mysteries from the beginning.
So, when you exercise, your body sweats, right? That sweat puts a layer of water on your skin for our energy thieves. As they start to evaporate, where they steal that getaway energy from? They steal it from you. They pull heat directly from your skin to power their escape, and that's what lowers your skin temperature and gives you that sweet, cooling relief.
You can feel this way more intensely with something like nail polish remover, which has acetone. If you put a drop on your hand, it feels crazy cold, doesn't it? That's because acetone evaporates way faster than water, which means it's stealing heat from your hand at a much higher rate. That's why you feel that instant, intense chill.
Okay, so what about the earthen pot, the matka? How does that work? The secret is all in its design. The clay is actually filled with these microscopic little pores, which allows a tiny bit of water to constantly seep through to the outer surface.
So basically, the pot is sweating all the time. As that water on the outside evaporates, it pulls the heat energy it needs from the pot itself, and more importantly, from the water that's still inside. This continuous energy theft is just a brilliant, low-tech way to keep water refreshingly cool.
All right, let's hit pause for a critical exam buster. This is a classic comparison question, and if you can nail the difference, it shows you really get this concept. Evaporation and boiling. They both turn liquid to gas, but trust me, they are fundamentally different.
Let's break down the key differences. First, temperature. Evaporation is slow and silent. It can happen on a cool day, a warm day, any day. But boiling, that's a fast, violent event that only kicks in at one specific, high temperature. And here's the biggest giveaway. Evaporation only skims molecules off the surface. Boiling happens throughout the entire liquid. That's what all those bubbles are. It's water turning to steam deep inside the pot.
Honestly, the easiest way to remember this is to just picture it. A puddle slowly disappearing on the sidewalk over a few hours, that's evaporation. Water going absolutely crazy with bubbles in a kettle, that's boiling. It's as simple as that.
Now that you understand the process, let's become masters of it. How can we actually control the rate of evaporation? How can we make it happen faster when we really need it to?
Let's think about a real-life problem. You have a party to get to in an hour, but your favorite shirt is still damp from the wash. What do? Well, the solution is all about manipulating the factors that control evaporation.
Here is your scientific plan of attack. First, spread that shirt out as wide as you can. You're increasing the surface area, giving way more molecules a chance to escape. Next, add some heat. Put it in the sun or near a heater. More heat means more energy for that molecular dance party. A fan helps a ton by blowing away the water vapor that's already escaped, making room for more to leave. And finally, a dry, non-humid day is your absolute best friend, because the air is just thirstier and ready to soak up a lot more moisture.
You see? All of those steps, spreading it out, adding heat, using a fan, they're all just different ways to help our energy thieves make a much, much faster getaway.
So let's lock in the #1 takeaway from all this. Evaporation causes cooling. It's not just some side effect, it's the whole point. The process absolutely requires energy, and it has to get that energy by absorbing it from its immediate surroundings. When that energy is pulled from your skin or from the water in a pot, the temperature of that surrounding thing drops.
And I'm going to leave you with one final question to think about, which brings us all the way back to our desert cooler. If the evaporation of our sweat is what cools us down, why on earth does a hot, humid day feel so much more miserable than a hot, dry day? The answer's hidden in the factors we just talked about. Think on that, and we'll see you in the next one.